Okay, students, welcome back. I hope you enjoyed your school holidays. Today, we are going to start with the new. This topic is something that you all should already have learned. We're going to learn something about whole numbers, but there are other concepts that we are going to touch on, which is going to include the highest common factor, and we are going to do some more complicated questions as well. Okay. But the first part should be quite manageable because it's about whole numbers. So what is number theory? Number theory is the study of numbers, okay? Let's take a look at some examples here. I'm sure most of you should know how to round up or round down the numbers. So what is the rule? Students, let me tell you the rule of rounding numbers, okay? First, you must ask, are you rounding to the nearest 10? Are you rounding to the nearest 100, right? Or are you rounding to the nearest 1,000 or the nearest 10,000? That can make a difference. So if you are rounding to the nearest 10, if you're rounding to the nearest 10, then you should look at the ones digit and you decide, should you round up or should you round down? If you're rounding to the nearest 100, you should look at the nearest 10 to decide whether you should round up or round down. So what are the rules of rounding? If the number is 5 or higher than 5, you always round up. If the number is lower than 5, smaller than 5, which means 4, 3, 2, or 1, you should always round down. That's the rule. So let's take a look at the first example, okay? We are trying to round to the nearest 10, and that means we should look at the ones digit. So if you look at the ones digit here, it is a 9. It is already more than 5. More than 5, round up. When you round up, what do you get? You get 21,150. Now, this one doesn't even have to be rounded. It is already a 10. So we leave it as it is. The next one, look at the ones digit. It is bigger than 5. So you round up. Okay, it is 5 or it is greater than 5. You round up. You get 60. Okay, the first few digits do not change, right? Only this is affected. It becomes a 6. Now, this is smaller than 5. So we round down. So students, which number when rounded to the nearest 10 is 21260? The answer is C. Okay? Okay, so what did I do? You notice that I went from A, B, C to D and I tested all the options. Okay, this is the safest way to do it. Just test all the options and then you get your answer. Let's take a look at practice number 1. They want you to round to the nearest 100. If they want the nearest 100, you should be looking at the tens digit. Okay, the tens digit here. So if you look at the tens digit for the first one, I notice there is a 9, right? So I round up to the nearest 100. It's going to give me 12100. Okay, I tell you what. I'm going to, since this is practice question, I'll give you 3 minutes. Can you all try the next 3 questions? Try the next 3 questions. Give me your answer. For example, if your answer is A, B, A, then I want you to type your answer all together. Give me 3 answers all together. Then you can just type A, B, A in the chat. Okay? 3 minutes. Everyone, try it now. Now, Owen, can you volunteer for question 1, please? So, Owen, let's do it from A to D, okay? For A, I've already helped you, 12100. Now, let's look at B. They want you to round off to the nearest 100. If they want it to the nearest 100, I should look at which digit? 5, yes. This is the tens placing. So, do you think this should be rounded up or rounded down? Rounded up. Yep. So, what do I get? 1, 2, what? 12200. Yes, correct. Now let's take a look at the next one. This is a 5. So what should I do?
Round up.
Yes, round up. What do I get?
12300.
Excellent. Next one.
12100.
Ha, yes, very good. Because this is a 4. So if it is a 4, you round it down. And the answer is
B.
B. Well done, Owen. Okay, no questions, right, Owen?
No.
All right. Good job. So I can see that everybody has the right answer, okay? Let's just circle the correct answer. Let's just quickly go through the correct answers. The nearest 10, you just need to look at the ones digit. Okay, so if you look at the ones digit, the ones digit is a 4. So we get 3, 4, 9, 6, 0, 3, 4, 5. Oh, because this is a number 5, so we round up 7, 0. This is a number 5. I'm going to round up 3, 4, 5, 6, 0. This is a 5. I'm going to round up 3, 4, 500. Okay, because this is already 90. The next thing after that is 100. So it has to be 500. And they're asking you for 34500. The answer is D. There you go. For the next one, the nearest 10. They want the nearest 10. So this one doesn't have to be rounded. It is already a 10. This is less than 5. Round down. This is less than 5. Round down. This is more than 5. Round up. So the answer is 5,000 here. C. Okay, students, I'll give you 1 minute. Can you all tell me what is the greatest whole number that can be rounded off to give you 12,900, rounded to the nearest 10? Give you 1 minute. Can you type your answer in the chat? Okay, students. So I can see many of you giving me different answers. I think the main confusion is it the nearest 10 or is it the nearest 100? If I want to round off to the nearest 100, no problem. I can give this answer, you see? Then when I round off to the nearest 100, I must look at the tens digit. The 10th digit less than 5. Round down. Okay, I round down. What will happen? Then I'll get this. Very good. This is correct. But the question is not asking for the nearest 100. The question is asking for the nearest 10. So if the question is asking for the nearest 10, okay, what must we do? We must look at the last digit. So for example, if I give this, sorry, 8, 8, what do y'all give? 1, 2, 2, 9, 2899, right? 2899. Yes. Okay, if I give this, then you want to round to the nearest 10, then you look at the last digit, which is the ones digit. You must round up. So when you round up, you'll get this. Yeah, this is correct. But this is not the biggest possible answer, okay? They want you to give them the greatest possible whole number. Therefore, okay, all these are wrong. Therefore, okay, as Zachary and Claudia has already said, has already given in the chat, the correct answer is 12904. Okay, and this will be rounded down because you look at the number 4. The number 4 is the ones digit, right? You round it down and you'll get this. So then the correct answer is 12904. If you give this answer, okay, or if you give anything which is greater, which is 5 or greater, the moment you see the number 5, it is rounding up. Okay, this is greater than 5, rounding up. When you round up, what will happen? You get 10. Okay, so these are both wrong. Any questions? Okay. Typo is it? Okay, yes, sure, Abby, go ahead. All right, students, let's go to the next page. Example 2. Now, over here, we need to make sure that we can find the highest common factor. Okay, students? So let's take a look. They have 108 apples and 72 oranges. So now what they're doing is, the question asks you to pack the fruits into small bags. Every bag should consist of a fixed number of fruit. What is the most number of bags that you can have? So, students, what is a factor? Firstly, we need to understand factors are actually the numbers that are being used to make up another number. For example, factors of 10. What are the factors of 10? We can use all these numbers to make up the number 10, right? So these numbers are called the factors of 10. The number 1, the number 2, the number 5, and the number 10. They are all factors of 10. Okay? So if I want to find the factors of 108 and 72, I just need to make a list. 108. Okay, I start off with 1 times 108. 2 times 54. 3 times 30 plus 6, 36. 4 times 27. 5, nope, 5 is not a multiple, 108 is not a multiple of 5. 6, yep, 6 times 18. 7 can or not? Nope, we can't do 7. 8, yes, 8 can be, 8 cannot be done. 9, can we do 9? 9 times 12, okay? 10 cannot, 11 cannot, 12, yeah, we can do 12. Uh-oh, we are starting to repeat the numbers. Please don't repeat. Once you repeat, you know that it's too much. Okay, delete it away. You can stop here. So these are all the factors of 108. So what are the factors of 108? 1, 2, 3, 4, 6, 9. Okay, 12, 18, 27, 36, 54, 108. There are 12 factors of 108. Now let's take a look at the factors of 72. Okay, we have 3 times 24. 4 times 18. 12. 8 times 9. 9 times 8. Oops. Starting to repeat. Please don't. Okay, delete it. We stop here. So these are all the factors of 72. Now, students, in order to find how many bags you can pack the fruit into, you need to find the highest common factor of 108 and 72. So what I'm going to do is I'm going to write down here the highest common factor of 108 and 72 is, everyone, can you help me? Can you look at all these factors? Look at all these factors. Which is the highest common factor for both of them? Can you all type in the chat group? No, it's not 18. Something even bigger than 18. Highest. Very good, Abby. Got it. Students, do you notice this number here? This number 36 is common. Okay, it is common between them, and it is also the highest. So the highest common factor is 36. So what I'm going to say is, therefore, there are 36 bags of fruit. So what are inside these 36 bags? Okay, imagine this is one of the bags. You just imagine that this is a bag, okay? We will have, students, can you type in the chat group? How many apples are there in each bag? And how many oranges are there in each bag? Tell me. I already know that there's 36 bags. By looking at the factors that I've written down, how many apples are in each bag? How many oranges are in each bag? Do you know? Very good. There are, as you can see, students, 3 times 36 equals to 108, right? Okay, Kate, you already got it, huh, Kate? So you know that 3 times 36 is 108. So if you take the 108 apples, you split them into 36 bags. Every bag must have 3 apples. Then you know that 2 times 36 is 72. So if you take the oranges and you split them into 36 bags, that means you will have 2 oranges in each bag. Therefore, every bag contains 5 pieces of fruit, okay, which includes 3 apples and 2 oranges in every bag. Any questions, students? All right, so let's try the practice. Now, for this question, okay, I will give you 2 minutes. Can you all try it out and type your answer in the chat? All right, Claudia, let's start from 82, shall we? 82 equals to 1 times 82. And what else? 2 times?
41.
Very good. Okay, you see this number 41, okay? It will help you later on. 1, 2, 3 equals to 1 times 1, 2, 3. And it also equals to?
3 times 41.
Very good. 3 times 41. Then finally, 205 is? What times 41?
1 times 5 times 41. 5
5
times.
times 41. Very good. What is the highest common factor?
41.
Yes. Okay, because we notice that the number 41 appears everywhere. It is common. Okay. So we say the highest common factor of 82, 1, 2, 3, and 205 is 41. And therefore, we can answer there are 41 students. Now, how many erasers did each student get? Now, Claudia, you answer first.
That one I'm not done.
No, I'm doing with you.
Oh,
Because you see, now we already know that there are 41 students, right, Claudia? Now, how many erasers are there? You read the question?
82.
Yes, 82. 82 is equal to 2 times 41, right?
Mm.
So how many erasers are there if there's 41 students? Well, there are 82 erasers. 82 eraser and 41 students. You distribute the eraser among 41 students. How many does each student get, Claudia?
2.
2. And how do you do that? Did you take 82 divided by 41?
Yeah.
You can do that, but you don't need to. Do you notice that the answer is already staring at you? Where? Here, right?
And yeah.
So you don't need to do your calculation. You can just look at the things that you have already written down. You know that they'll get 2 eraser. Then if I ask you how many books will each child get, what's your answer gonna be?
3.
Yeah, the answer is just here. And how many pencils?
5.
Yes, easy, right? Very good, Claudia. Well done. Okay, students, anyone have any questions? I'm going to write down the answer, okay? Sorry. Each student gets 2 erasers. There you go. Anyone has any questions? No? Okay. Now let's look at question 6. Same thing. They want you to find what is the most number of stacks of coins. Now, I'm going to get a volunteer for this because there's actually a long way and there's also a short way. Now, before I get a volunteer, I'll show you the long way. I tell you, most of you might want to do this. 150, right? Okay, 2 times this, 3 times this, 4 times, cannot. 5 times this, 6 times this, 7 cannot, 8 cannot, 9 cannot, 10. Okay. Okay, so you might want to do this. And then you're going to do this. And then you're going to do this. Now it's going to waste a lot of time. It's going to waste a lot of time because you're going to write a lot of steps, okay? So what I want you to do is this. We're going to do a shortcut. Can I ask Kate? Kate, do you think I need to write down everything for 150, 180, and 420?
No.
This is what students will usually do, right?
Yes.
Now, Kate, do you notice that every one of these numbers ends with a 0?
Yes.
Yes, it does. Now, what kind of shortcut do you think I can do? Instead of using 150, 180, 420, all of them ends with a 0. Instead of using all those big numbers, what numbers can I use?
You can divide 180 into 90 and 90.
No? Okay, Owen already knows. Yes, Owen, you're correct. That's a shortcut. Kate, I don't need to use all these big numbers. I want to make them smaller. I noticed that every one of them ends with a 0, right?
Yes.
I'm gonna get rid of the 0, okay, Kate? Okay, let's get rid of the 0. So why not you help me out here? I have the number 15. 15 is 1 times 15. What else?
3 times 5.
Okay, what else?
No more.
No more. Very good. Can you see how short this is, Kate?
Yeah.
Compared to 150, this is so short, right? Now let's try the next number. What's the next number?
18.
Yes.
1 times 18, 2 times 9, 3 times 6.
Nice. Very good. Very fast. Next, what is the next number?
The next one, 42.
Good.
1 times 42, 2 times 21, 3 times 14, 4 times 13,
Haha.
6 times 7.
Yes. Okay. 4 times 13 is 52. Okay. So 6
Alright.
times 7 is 42. Very good. So do you notice that the workings that I'm doing is so much shorter?
Yeah.
Now, what is the highest common factor between all these numbers?
Highest common factor is mm, 3.
Yes, you are totally correct. The highest number that appears for all of them is 3. So what I'm going to say is the highest common factor between 15, 18, and 42 equals to 3. So Kate, what if now I want to know the highest common factor between 150, 180, and 420? What do you think will be the highest common factor between them? Owen, you're correct.
The highest 30.
Yes, very good. You just need to add the 0. Okay, so this is the shortcut. Now, Kate, now that we know the highest common factor, can you tell me what is the most number of stacks of coins that you can form?
There are 30 sacks.
Yes. 30 stacks of coins. And how many silver coins are there in each stack?
There are 6.
Yes, the answer is right in front of us because there's 180 silver coins. So you go to the number 18, right? The number 18, you can see that it is 3 times 6, or you want to say 30 times 6 is 180. So there will be 6 silver coins. Well done, Kate. Good job. Students, any questions? So you can see that sometimes when everything ends with a 0, just take the shortcut. You don't have to waste your time. But if one of them does not end with a 0, then obviously you cannot do this shortcut. Every one of them must end with a 0. Then you can use this shortcut, okay? So, students, now we have a different type of question. The question is telling us that the sum of two distinct positive integers is 50. What is an integer? An integer is actually a whole number. But the difference between a whole number and an integer is that the whole numbers, right? It starts from 0 and it goes upwards to the positive numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. But integers can go to the negative numbers. -1, -2, -3, okay? But both of them, they do not, whole numbers and integers, they all do not contain decimal points and they do not contain fractions. Okay, so what is the meaning of distinct? So let me ask Nicholas to volunteer for this. Okay, Nicholas, what is a distinct number? Do you know? Okay, distinct means unique. That means it is not the same as others. Every number must be different. Okay? So I can just say distinct means unique. Or I can say different. So that means they do not repeat themselves. Okay? Find the maximum value of the highest common factor. Okay, so Nicholas, what's happening here? Over here we have some options A, B, C, and D. They are telling you that the sum of two positive integers is 50. What is the maximum value of their highest common factor? Any idea? Okay, so let's take a look at some examples. Okay, let's take a look at all these numbers here. We have 15, 18, 42, and we realize something. Look at the highest common factor, number 3, correct? If I were to take the sum of these 3 numbers, can you help me to calculate what is the sum of these 3 numbers?
$75.
Yep. 75, okay, Nicholas? So if it is 75, right? There is actually another way that I can get the answer 75. And it is by using the highest common factor. Let me show you. I'm going to take the highest common factor and I'm going to multiply the highest common factor by this number plus this number plus this number. Nicholas, what is 5 plus 6 plus 14?
25.
So you notice that when I add these 3 numbers, I get 25. 3 bracket 25. Whenever you see a number beside a bracket, it means multiply. Nicholas, can you help me multiply 3 times 25? Three times 25.
75.
Yes, you notice you get the same answer here and here. Right, Nicholas? So when I have three different numbers, I add them together, I get the sum, right? I can get the sum by adding them together. However, there's another way to get the total sum. You make use of the highest common factor. You multiply it by the corresponding numbers here. You see the number 3 is together with the number 5, right? This number 3 is together with the number 6. 3 is together with the number 14. So that's why I take 5 plus 6 plus 14. I add them together and multiply, I'm going to get 75. Okay, so let me just erase all this. Then we can go back to the previous question. So just now, based on our small experiment, what did we do? What we did, right, was that we took the highest common factor, right? We took the highest common factor and we multiplied it by the numbers inside the brackets. Let's say that we do not know what are the numbers inside the bracket. Over here, we have two distinct positive integers. So in this case, I'm going to use two different numbers. Let's call it A and B. Okay. So for example, if I take, okay, let's just say that if the highest common factor is 25. Okay, how did I know? Where did I get the number 25? I'm just simply choosing the largest number. Okay. Why am I choosing the largest number? I'm choosing the largest number because the question is asking me for the maximum value. What is the maximum value of the highest common factor? So since this is the maximum, I'm going to just do an experiment to see whether this is going to work. So let's choose the number 25. Let's just assume that the highest common factor is 25. So what I'm going to do next is I'm going to test whether I can get a sum of 50. Okay, so let's do some testing. I take the highest common factor and I do the same thing that I did just now, but I do not know what are these two numbers. I do not know because I don't even know what are the original numbers. So I don't know what are these two numbers. I'm just going to call it A and B. And the question says that the total sum is going to be 50. So Nicholas, 25 times A plus B equals to 50. Can you tell me what is the value of A plus B?
2.
2, definitely. Correct. A plus B must be 2 because 25 times 2 is 50. If A plus B equals to 2, therefore, I can say that A equals to how much?
1.
Yes. A equals to 1 and B equals to 1. Now, Nicholas, this is the important part. Are they distinct, A and B?
No.
No, they are not distinct. Okay, so what we do is we reject them. We reject the answer because it is not distinct. The question is asking you for distinct. So apparently it does not work for the number 25. Let's go down and test the next bigger number. Number 10. Okay, let's test. If highest common factor is 10, so I use the highest common factor multiplied by my A and B. I'm supposed to get a sum of 50. So what is A plus B, Nicholas? Ten times what is 50?
5.
Yes, 10 times 5 is 50. So if this is the case, A plus B must be 5. Therefore, A equals to how much and B equals to how much?
A equals to 2.
B equals to?
3.
Yes, okay, there can also be another possible answer. A equals to 1, B equals to?
4.
And do you notice that all of them are distinct?
Yes.
Very good. So does it work for the number 10?
Yes.
Very well done. So our highest common factor will be 10. Any questions about this, Nicholas?
No.
All right. So students, what did we learn? Okay, let me revise before we move on. When you go back here, you notice that you can actually make use of the highest common factor to find the total sum of the numbers. 15 plus 18 plus 42, you get 75. But if I take the highest common factor 3, then I multiply it by the bracket 5 plus 6 plus 14. I'm going to get 3 times 25. I'll get 75. So I can use this knowledge and I'm going to test out the numbers using the bracket. Can you see the bracket I'm using? Even though I do not know what are these numbers, I'm just going to test. I start with this. The question already said that the sum is 50, right? Then I just need to test whether the answer is going to be distinct. If it is not distinct, then I don't want it because the question say distinct. But now I got something which is distinct. So therefore, this is the correct answer. Any questions? Raise your hand. Okay, let's try the next one then. Y'all can start testing from 175. Okay, you can just say that, okay, 175. How many numbers are here? 3, right? 3 numbers. So you just say A plus B plus C. And what is the sum? 525. Okay. So then you know that A plus B plus C equal to what? 3, right? Is it? Yeah, it's 3. Because 3 times 175 is 525. So then you can say that therefore A equals to 1, B equals to 1, C equals to 1. And you realize that, hey, I'm going to reject this because they are not distinct. Okay, so it does not work for this number. Now, students, I want you to continue go ahead and continue testing for 105, 75, 35. See which one works. They want you to find the maximum value, the largest possible value. So you always start from the biggest one and you slowly test them until you get the correct answer. Now, I'll give you 2 minutes. Can you all go and test out the other numbers? See which one give you a distinct value. So, Zachary, let's continue testing the next one, shall we? Let's test the number 105. This is the highest common factor, assuming. We are assuming that this is the highest common factor, and we do not know which are the 3 numbers. And we do know that the total sum should be 525. So, Zachary, can you tell me what is A plus B plus C? Zachary, help me. Yes, you're correct, Zachary. Your answer is correct, but can you help me with the workings?
It's 5.
Yeah. So in this case, we can say that A equals to how much? Okay, let's say A equals to 1. Then B,
3,
B equals to 3. Then C equals to?
1.
So is it distinct or not?
No.
Because the A and the C is repeated. Same, right?
Yeah.
Then what about another way? Maybe we can try A is 2. Then B is what?
And B is 2.
C is?
1.
You see this repeated, correct? So it is not distinct. What should I do? If it is not distinct, what should I do?
And reject.
Reject. Yes. Now we move on to test another one. 75, which is your answer, right?
Yeah.
Okay, then this is 525. So what is A plus B plus C?
7.
7. So what is A?
And 2.
Let's say it's 1. Okay, then B
And 2.
and C.
4.
Are they all distinct?
Yes.
Done. So
Yeah.
then we can say that the answer is 75. Easy or not, this one?
It's a bit hard.
But you understand?
Yeah.
Well done, well done. How about the rest of you? Anyone have any questions? Raise your hand. Want to clarify anything? Okay, let's move on to the next question. Now, students, in this case, it is a little bit different. Now they are giving you 4 numbers. Not only 3 numbers, right? Now there's 4 numbers. And they gave you the total sum is 1111. And they did not give you any options, you know. They did not give you multiple choice, you know. So how are you going to know what number to test? The truth is, we don't know. We don't know, okay? I think, let me get Abby to help out with this, Abby. So Abby, I tell you what, since they didn't give us any multiple choices, I don't know where to begin. Why not I do this? Why not we just let the highest common factor be the letter K? Okay, just some random letter that I came up with. You can call it X, you can call it Y, up to you. I'm going to call it K, okay? So, given the same format that we have been using, we can say that if you take the highest common factor, there are 4 distinct integers now. So, Abby, what should I be writing inside the bracket?
A plus B plus B, C plus D.
Very good. Now I have 4 alphabets inside. And the sum equals to
1111.
yes. Now there's a little bit of guessing involved over here. I cannot immediately tell you what is A, B, C, D. But I do know that I would love for this to be maximum. I need this to be as big as possible, right, Abby? So if I want the number K to be as big as possible, therefore, the number A, B, C, D, should I make it as small as possible or as big as possible?
As small as possible.
Yes, as small as possible. Correct. If you want the K to be big, then the ABCD must be small. All right? Because a very simple illustration is like that.
I'm halfway through the banking.
Okay? So let's imagine that this is your K. Let's imagine that this is your ABCD, right? If your ABCD is very big, your K is very small. But if your K starts to get bigger, do you notice that your ABCD is going to get smaller? Because this number will not change. This is your sum. It is always the same. It stays the same. Yeah. So if you want one side to be bigger, the other side must be smaller. That's all. So can you guess? Let's try to guess a very small number for A, B, C, D. And they must be distinct. Okay, so Abby, you cannot guess the number 4. Because if you guess the number 4, that means A equals to 1, B equals to 1, C equals to 1, D is 1. They are not distinct. They are not distinct. You cannot guess this. You must guess something which makes them all unique. So what will you guess, Abby? What is A? Let's start with 1. What is B?
2.
2. What is C?
5. 3.
Just guess. As long as they're all different and as small as possible.
3.
What will you guess for C?
3.
3 and D?
4.
Okay, they add up to 10, right? Do you think 10 is a factor of 1111? Do you think 1111 can be divided by 10? No. What do you think it can be divided by, which is very close to 10?
11.
11. So instead of making D equals to 4, can you change the D?
Yes, you can make it 5.
Very good. So let's write it down, okay? Let A, B, C, D be 11. Okay? Which is actually 1, 2, 3. So therefore, K should be 1111 divided by
11.
11. And therefore, K should give you what answer?
101.
Well done, Abby. Good job. Found the highest common factor. So, Abby, do you find that this question is easy or difficult?
Easy.
Well done, well done. Anyone has any questions, raise your hand. Okay, it makes sense, right? Because the format is the same. We are taking the highest common factor multiplied by the brackets. We have 4 alphabets because there are 4 distinct numbers. We make sure that the total sum is 1111. We also make sure that this is actually as small as possible. And if this is as small as possible, then this is going to be as big as possible. And that's how you solve it. Right, students? All right, let's try the next one. All right, can I get Owen to volunteer for this? Hello, Owen. So, Owen, tell me, what are all the prime numbers starting from the smallest? Oh, Owen is not here. Owen went to the toilet, is it? Okay, okay. Let's try Claudia. Claudia, tell me, what are all the prime numbers starting from the smallest?
That is
What are prime numbers?
like numbers that only can be multiplied by them.
Can be divided
I
by
mean, divided by
number 1 and
and itself.
very good. Prime numbers are numbers that can only be divided by the number 1 and itself. Which is the smallest prime number? Is it number 1?
No, 2.
2, yes. Now, the number 2 is very special. It is not only the smallest prime number, but it is the only prime number that is
Even.
yes, even. All the other prime numbers are odd, right? Okay, so come, this is the smallest one. Then what's the next one?
3, 5,
7, 11,
7, 11,
13, continue.
19,
17, 19, 21, right? 21, right?
I think.
No. Okay, 21 can be divided by 3, can be divided by 7. So what is the next one? 20 what?
3.
3. Okay, then 27, right?
No.
No, then what?
29.
And that's 30.
31.
31,
37.
37. Very good. Okay, I think that's enough for now, yeah? So now we have made a list of prime numbers. Can you tell me 2 numbers? Because they say product. What's the meaning of product?
Multiply.
Multiply. That means you take 2 prime numbers, you multiply them together, you get 93. Can you look at all these prime numbers and tell me which 2 prime numbers that when you multiply together, you get 93? Oh, if you already know, you all can type in the chat group. Those of you who already know, you can type in the chat group also. Kate, can you type your answer? Which 2 numbers multiply? Very good, Nicholas. Very good, Kate. Yes, correct. Yeah. Kate, you want to put down your hand or you still have a question? Okay. Okay, Claudia, I give you a hint. One of them is the number 3.
3 times 31.
Yes, okay. 3 times 31 is 93. And therefore, what is the sum of the 2 numbers?
34.
Yes. Easy or not? You got it? Well done, Claudia. So, students, this is how we do it. Can I give you this? We already have a list of prime numbers here. Okay, if you want to make use of this list of prime numbers, go ahead. I'm not going to erase it. I'm going to leave it on the screen for you. Take a look at question 9. Can I give you 2 minutes to solve it? Give me the sum of the 2 prime numbers. Now, can I ask Kate, which are the two numbers that when I multiply together will give me 119? Do you know?
No.
7 and 7 times.
I
Okay, 7 times 7 is
49.
49. So you already got a 9 there. Do you think
Okay.
7 times what?
17.
Very good, Kate. 7 times 17 gives you 49. And therefore, what is the sum of these two numbers?
No, 7 times 17 is 119.
Sorry. 119. Yeah. So what are the sum of these two numbers?
So 7 plus 17 equals 24.
Easy. You got it, Kate. Well done. So I think the only part that was difficult is trying to figure out which are the two numbers, right?
Yeah.
Okay. Anyone has questions? Okay, now let's take a look at question 10. Now, this question I think you should have seen before, right? How many of you seen this before? I remember giving it to you before. Very good. So, Kate, do you think you know how to solve this?
Maybe.
Okay, come.
So you take 2910 and make it into 2-digit numbers.
You mean break it down?
Yeah. Some
Good. Okay, well done. So, Kate, help me to break it down. 2910. If I were to break it down, okay, I'll get 291 times what?
209 2910
291 times
1 and 10.
yes, 291 times
10
10.
is 2 and 5.
291 times 10 gives you 2910. 10 equals to 2 times 5, correct? Then 291 equals to 97 times
97 times 4.
not 4, a little bit smaller than 4.
3.
3, got it. 97, can I break it down?
No.
No, it is already a prime number. Very good. So we circle all the prime numbers. And we can therefore say that 2910 is equal to 2 times 3 times 5 times 97. So, Kate, this girl Zoe, she's trying to tell her friends the age, her exam score, and her rank. Okay? Now, looking at all these numbers, what do you think is, let's start with her rank, okay? Or let's start with her age. What do you think is her age?
She is 5, I think.
She's 5 years old. Okay,
She can't be 97.
so she's 5 years old. Okay, we have
No,
used,
no, but the age, rank, and score, there are only 3 categories. You have to put 2 numbers together.
yes, the age, rank, and score are 3 categories. You have 4 numbers here. You're definitely gonna have to combine 2 numbers together.
2
But
and
never, but never mind, you can do it later on. Let's say your age is 5. Then what do you think is her rank?
2.
2. Okay, you already use up the number 2. Then what's her exam score? Are you going to combine these 2 numbers together?
No, your exam score is the highest is 100.
Yeah, usually it's 100. So why not you combine some other things? Okay, let's start from scratch. What is her age?
So no, her score is 97.
Her score is 97. Okay, good. That is very
Her
big.
age is 6 and her rank is 5.
Her age is 6 years old and her rank is 5. Can we read this part? What is this?
Her age is a 2-digit number.
Even.
3 times 5.
Even.
No.
Even. Can you see this word?
2 times 5. 2 times 5.
Very good. You combine the number 2 and the number 5, you're going to get 10. So her age is 10. And what is the number that you are left with? What number have we not used? We used the,
Three.
yes, 3.
Rank is 3.
3 is the rank. Well done, Kate. Good job. So students, this is how we do it. We break down the number because why? Because she's actually giving you the product of her age, the exam score, and the rank. That means she take her age, multiplied by her exam score, multiplied by her rank, she got 2910. So if we want to find out the individual numbers, we have to break it down. So I've broken it down, but when I've broken it down, I got 4 different numbers. But it's okay. You can combine 2 of the numbers and you'll end up with 3 different components. And of course, it's important to read the question. The age is an even 2-digit number. They already gave us a very good hint. So we know that the age must be 10 years old because we are combining the number 2 and the number 5 to get 10 years old. Okay, you cannot combine anything else. If you combine 2 and 3, you get 6 years old. This is not a 2-digit number. It must be 2-digit, right? So the only possibility is 2 times 5. That is her age. Anyone have any question? Raise your hand. Okay. So, moving on. Okay, take a look at this question. They want us to find the smallest positive integer such that neither 4n minus 1 nor 4n plus 1 is going to be a prime number. We do not know what is n. Okay, now let me tell you what is the meaning of 4n. Whenever you see a number which is right beside an alphabet, it means multiply. Okay, if I say 4n, it means 4 times n. 4 times n, understand? If I say 4x, that means 4 times x. If I say 10y, that means 10 times y. So whenever you see a number beside alphabet, it's multiply. Now, they are asking you for the smallest possible integer n. So you don't know what is n. N could be 1, 2, 3, 4, 5, 6, 7, 8. I don't know. It could be anything. So let's just write down, okay, 4n. N could be anything. If n equals to 1, then 4n is 4 times 1. If n equals to 2, then 4n will be 4 times 2. If n equals to 3, then 4n is 4 times 3. So you can go on and on and on, you know. I do not know what is n. Okay, you can go on. These are just some possibilities, okay? I'm just writing down some possibilities. You can go on. It depends on what is n, right? So students, what does the question ask for? They want it to be such that if you take 4n, you minus 1, it cannot be a prime number. Or if you plus 1, it cannot be a prime number. Let's do an experiment. Let's try it out with this number. This is 4n, right? 4 times n. In this case, n equals to 3. N equal to 3. That means 4 times 3 is 12. So let's do an experiment with the number 12. If I minus 1, I get this. If I plus 1, I get this. Both of them are prime numbers. So do I want this? No, I don't want it. Okay? They don't want it to be prime. So I should not be choosing the number 12. Let's do an experiment with another number. Let's say this number. If I minus 1, 4n minus 1, 4n minus 1 is 51. 4n plus 1 is 53. You see, I'm getting prime number again. Right? So do I want this number? I don't want it. So students, can you just observe all these numbers that I've written down? Can you just take some time to choose which number, right, is the smallest possible number such that if you minus 1 or if you plus 1, you will never get a prime number. Can you type in the chat which number do you want to choose? So I can see that most of you have chosen the number 64. Yes, this is totally correct. 64 plus 1, 64 minus 1 is not a prime number. 64 plus 1 is also not a prime number. So this is definitely correct. However, the question is asking you for the smallest. Okay, there is a number that is smaller. A little bit smaller than 60. 56. Okay, let me show you, students. Since 56 minus 1 and 56 plus 1 is not prime. Okay, therefore, 4n equals to 56, which leads us to conclude n should be 14. Students, this will give you 55, right? It's not a prime number. Huh? This will give you 57, right? Is 57 a prime number, student? What is 5 plus 7? Okay, let me ask Nicholas. Nicholas, what is 5 plus 7?
12.
Is 12 divisible by 3?
Yes.
Is 56? Is 57 divisible by 3?
Yes.
Yes. Okay, because what is the rule? How do you know that a number is divisible by 3? Okay, let's say I give you this number, Nicholas. 1, 2, 3. Do you think this number is divisible by 3?
Yes.
How do you know?
Add all the digits up and
Very good. Add the digits up. 1 plus 2 plus 3 is 6. And if you get an answer that is divisible by 3, that means the entire number is divisible by 3. So 57 is divisible by 3. So is 57 a prime number?
no.
No, because it's divisible by 3. Very good, Nicholas. So as you can see, students, 57 is also not a prime number, right? So the smallest possible value of n should be 14. Okay? Any questions? All right. Come, let's try the next one, students. Now, over here, we are learning about power. 7 to the power of 0 equals to 1. In fact, I can tell you this. Any number to the power of 0 is always going to give you 1. Okay? Now, 7 to the power of 1, that means you multiply the number 7 one time. Power of 2, that means you take the 7, you multiply 2 times. Power of 3, that means you multiply them 3 times together. All right? Find the units digit of 7 to the power of 55. Power of 55 means that you take the number 7 and you multiply them together 55 times, you know. Wow. Do you think we should be doing this? By the time we finish doing this, the exam is over, right? So, we should not take the number 7 and literally multiply it 55 times, right? What we can do, students, is to make a table. Okay, let's make a table. Okay, I don't need it to be so long. Okay, something like that will do. This is the power, and this is the units digit. So students, what is the meaning of units digit? The units digit is the ones digit. The ones digit is at the end, the last digit. So let's take a look at the power. If we take 7 to the power of 0, we get 1. If we take 7 to the power of 1, we get 7. Okay, as you can see from here. Okay, so anything to the power of 0 is 1. Then to the power of 1, that means you just take the number by itself. Power of 2, that means you take it and multiply it 2 times. You get 49. So power of 2, I'm going to write down the number 9. Why? Because they are asking for the units digit, which is only the ones digit. They are not concerned about the other digits. They are only concerned with the last digit. So I'm just going to write down the last digit, which is 9, okay? Then next, you'd have 7 times 7 times 7. Okay, you already know that this is 49, right? So you times 7 again. What is the last digit going to be? I only need to care about the last digit. Look here. 7 times 9, 63. I'm not even going to bother to work out the entire multiplication. 7 to the power of 3, the last digit is 3. So I just write down 3. Okay, then to the power of 4. To the power of 4, what does it mean? That means you multiply by 7 again. Okay, so if you multiply by 7 again, the last digit, 3 times 7, the last digit is 1, 21, right? So the last digit is going to be 1. You keep on multiplying by 7, okay? Keep on multiplying by 7. You realize that you will form a repeating pattern. So the repeating pattern is 1793, 1793, right? Okay, we can use this to help us. Okay, where's my red pen? There you go. We notice that the number is repeating. It is repeating in groups of 4, or you can call it a cycle. Okay, let's say that this is a cycle of 4 numbers. Okay, so when we have the power 0, 1, 2, 3, it keeps on repeating. It is one complete cycle. 4, 5, 6, 7, it is another complete cycle. They want us to have the power of 55. Now, before we do that, what we're going to do is, since it is repeating in cycles of 4, I'm going to take the power and divide it by 4. If I divide it by 4, I realize that the remainder is 0. 0 divided by 4, the remainder is 0. 1 divided by 4, the remainder is 1. 2 divided by 4, the remainder is 2. 3 divided by 4, remainder is 3. 4 divided by 4, there is no remainder, 0. Okay, remainder is 0. 5 divided by 4, remainder 1. Then you can see the pattern. Okay, remainder 1, remainder 2, remainder 3, remainder 0. 1, 2, 3, 0. 1, 2, 3, 0. Now, we can take 55. If you take the power 55, divide by 4, the remainder is 3. So if the remainder is 3, it corresponds to the number 3. Do you realize? Then we can say, therefore, the units digit is 3. There you go, students. Okay? Anyone has questions about this? What did we do here? We spotted a pattern. And we made use of this pattern to figure out which number corresponds to the power of 55. How do I know what corresponds to 55? I take 55, I divide it by 4. I realize that the remainder is 3. And all these, whenever the remainder is 3, I realize that the last number is 3. The units digit is 3. Therefore, I can conclude that the units digit must be 3. Okay, let's try out the practice question, okay? Now, students, they want you to find the units digit for this power of 100. So, same thing, okay? We are going to draw a table. And you can write down the power here. And this is the units digit. 0, 1, 2, 3, 4, 5, 6, 7, 8. You know, you can go as long as you want. But Usually the pattern will repeat after 4 times. Usually, okay? Now, 13 to the power of 0. Any number to the power of 0, you get 1. 13 to the power of 1 equals to 13. You just need to write down the ones digit. 13 to the power of 2. You just keep on multiplying everything by 13, but you only need to write down the last digit. Okay, you just keep on multiplying by 13, but you only need to write down the last digit. Then you will start to see a repeating pattern. I'm going to give you 2 minutes to try out this question. Can you type your answer in the chat? So, Owen, have you completed your table? Can you tell me what numbers are in the what number comes after 9? If you multiply 7, yes, 9 times 13. You take the 3 times 9, you get 27. So you just write down the number 7. Then 7 times 13. 3 times 7 is
1,
21. So you just write down the number 1. Then you times 13 again. What do you get?
3,
And 3 times 13. What do you get?
9,
Very good. Okay, so Owen, this pattern repeats in a cycle of how many numbers?
4,
Yes, since it repeats in a cycle of 4, I'm going to divide everything by 4. 0 divided by 4, remainder is?
0,
Yes, then this is remainder 1,
1,
remainder 2,
2,
remainder
3,
3. This
4.
one, remainder 4, is it?
Yeah.
Wrong,
Wait,
wrong.
no, don't have.
Remainder 0. Next, remainder?
1,
This one, remainder?
2,
Very good. So, they want you to find the power, 100. What do I need to do now? Take 100 and divide by?
remainder.
Divide by what? Divide by what?
4,
Ah, so I take the number 100, I divide by 4. I realize that the remainder is?
25.
The remainder.
Oh, yeah.
Remainder is? Ayo, what's the remainder? Any remainder or not?
Wait, I don't remember there was. It's just 25.
So is there a remainder?
No,
So what's the remainder?
0.
0. Yes. So if the remainder is 0, which unit digit does it correspond with?
1.
Well done. So I can say therefore the units digit is?
13 times 1.
Sorry, say again.
1.
1. Well done. The unit digit is 1. So how do you
Wow.
find this? Do you find this easy?
Super easy.
Super. Oh, then you never type your answer.
Next question when the answer is 1.
Next question. What? Oh, you type already. Okay. So well done, Owen. Students, any of you have any questions? Raise your hand. Anyone? Okay, now it is time for the challenging problem, and it looks very intimidating, right? You have a X, you have a A, you have a B. Oh my gosh, what are they trying to do here? Now, students, don't be surprised, okay? This question is actually a little bit similar to what we have just done. Okay, what we have just done, it is actually to find the units digit, which is the last digit. Over here, they're asking you for the last 2 digits. Okay, they're asking for the last 2 digits. So let's just take an example. Let's say I have 7 to the power of A. Now, of course, I do not know what is A, right? So if it is 7 to the power of A, okay, let's say A starts from 0. Okay, A equals to 0. I already told you that anything to the power of 0 equals to 1. So the last 2 digits should be 1. 0, 1, 0, 1. Okay. If A equals to 1, okay, then the answer is just 7. The last 2 digits is just 0, 7. I mean, usually we don't write 0, but in this case, I'm just going to add a 0 because we are assuming that this number has a last 2 digits. So it might be a 3-digit number. It might be a 3-digit number. The last 2 digits can be 0, 1, or it can be 0, 7, okay? Then if it is 7 to the power of 2, 7 times 7, 49, right? The last two digits should be 49. If it is 7 to the power of 3, then 49 times 7 is 100. 243. So we can just write down the last two digits, 43. Okay, and it goes on, it goes on. After this, you times 7 again, you repeat 0, 1. Okay, then you repeat 0, 7. So it goes on and on and on. What about 12? Sorry, not 12, 21 to the power of b. Again, anything to the power of 0 is always 1. Then 21 to the power of 1, obviously is 21. 21 to the power of 2, that means 21 times 21. So if you take 21 times 21, right, we're going to get 441. So 441, the last two digit is 41. Then again, you take 41, you times 21. Okay, the last two digits in this case is going to be 61. Then you times 2 again, not times 2, you times 21 again. The last two digits should be 81. And then after that, you times 21 again, it goes back to 0, 1. Then you times 21 again, it starts to repeat itself already. So let me highlight the pattern to you guys. This is the pattern. The last two digits repeats itself like this. Okay? Oh, I think I better draw this properly. There you go. So the last two digits repeats itself like that. So do you notice that they gave us a table here? What is the purpose of this table? So first, what we're going to do is, we are going to fill in the table, okay? What is the remainder for the power of A? Now, what do I mean by remainder? Because A repeats itself in a cycle of 4, right? Remember, we have all these remainders here. Remainder 0, remainder 1, remainder 2, remainder 3. So if it is remainder 0, 1, 2, and 3, then what are the last two digits? We will fill it in later on. Now, over here, we are going to get the remainder for, let's just write it down, remainder for 21 to the power of b. And again, it's going to be 0, 1, 2, 3, 4. So let's start filling it in, shall we? Why do you think, okay, look at the number of patterns here, 1, 2, 3, 4, 5. There are 5, this 21 to the power of b, it repeats itself every 5 times. So why am I not finding the remainder of 5? Sorry, I'm already finding the remainder of, I'm already finding 5 remainders, right? 1, 2, 3, 4, 5. Why? Because it repeats itself every 5 times. Okay, and you notice for the other one, I'm finding 1, 2, 3, 4. 4 remainders. Why? Because it repeats itself in a cycle of 4. So you find 4 remainders. Now we are going to find out what happens if, when you have a remainder of 0, okay, you look here. What happens when you add them together? Do you notice that there's a plus sign, students? When you add them together, 0, 1 plus 0, 1. What are the last two digits? 0, 1 and 0, 1, you add them together, you end up getting 0, 2. Yes, students? Now let's look at the remainder of 1 here. Okay? Okay, I'll just write down remainder 0, remainder 1, remainder 2, remainder 3, and over here is the remainder 4. Okay? So students, if I add up the remainder 1 and the remainder 1, okay, or let's find out what is this. This is when you add up the remainder 1 and the remainder 0, right? The remainder 0 for 21b is 0, 1. The remainder 1 for number 7a. 7a is 0, 7. So 0.1 plus 0.7 gives you 0.8. So we have to fill in this table, right? So can I give you 2 minutes? Can you all fill in this table before we continue? Now, Zachary, can you tell me when you have the remainder of 2 for 7a, right?
Yeah.
Which number are we looking at? Which are the last 2 digits?
wait, what?
When you have remainder 2 for 7a, what number is that? The last 2 digits is
Is
49.
49, yeah.
When you have a remainder of 0 for the 21b, which number does it correspond to?
7.
Remainder of 0 for 21b, which number does it correspond to?
1.
0, 1. So you take 49 plus 0, 1, what do you get?
49 plus 0, 1 equal 50.
Yes. Now let's look at remainder of 3. Remainder of 3 corresponds to which number here?
43.
Then remainder 0 corresponds to which number?
1.
0, 1. So 43 plus 0, 1 is?
44.
Yes. Very good. Let's try one more, okay?
Uh,
Okay. You start from the remainder 0.
1.
Then what about this remainder 1 here?
21.
21. Yes. 21 plus 1 is?
22.
Correct. Okay, so the number 22 should appear here. Now you get how to fill up the table?
Yeah.
Okay, very good. So students, this is how you fill up the table. Now, after going through the same process, we shall continue filling up the entire table. Okay? Now, after filling up the entire table, let's go back to the question. Which of the following could not be the last 2 digits of our x? What is x? X is 21a plus, 7a plus 21b, right? So what, out of all these multiple choice options, okay, which number did not appear in this table? That means it is not possible to appear as an answer, as the last 2 digits. Okay, can you all type your answer in the chat group? Which out of all these multiple choice that they gave you will never appear? Yes, Abby, very good. Okay, the answer is 20. The number 20 did not appear. Okay, do you realize that, students, no matter how you do it, right, the only possible last 2 digits for 7a plus 21b will always be only all these numbers. You will never ever get anything else. Okay, because the last 2 digits repeat itself in this cycle. No matter what combinations you get, all these are already all the possible combinations of the last 2 digits. You will never get anything else other than all this. Okay, so you will get, so therefore, when they ask you which of the following could not be the last 2 digits, then your answer should be A. Okay. So students, I know that this is not easy. It is a challenging problem after all. Okay. Anyone want to clarify anything? Raise your hand. Now, for challenging problems, right? I do not expect you all to know how to do it immediately. Okay. But what you can do to improve, to stretch your potential, to stretch your ability is maybe after 1 or 2 days, you can come back and look at it again. Or you can review the video recording because I've recorded the lesson, right? Then you can slowly start to understand more. Whenever you read something for the second time or for the third time, you will discover more and you will you will notice more things. Okay, and that's where your understanding deepens. So students, well done. We have managed to complete the worksheet and even the challenging problem. So what did we learn today? We learned about rounding up numbers. We learned about powers of numbers. We did some prime numbers as well. And more importantly, we also learned highest common factor, right? So students, please go and do your revision. The solutions will be uploaded and the lesson recording is going to be uploaded in the Genius portal. Okay, if you have any questions, you can stay back. But if you don't have any questions, I'll see you next week. Bye, everyone. Bye, Claudia, Nicholas, Owen, Zachary, Kate.